All right, we're going to talk about continuity. The function f is continuous at c if the limit of f of x as x goes to c equals f of c. So if you can find the limit by plugging in the value, okay, then it's continuous at that point. The function f is right continuous at c if the right-hand limit exists and it's equal to f of c. So if you're taking values from the right, plug it into f of c. The function f is left continuous at c if the limit of f of x as x comes from the left-hand side is equal to f of c. So we have some continuity test. So 3 steps. First, f of c exists. I can take the value and plug it in. Okay, it exists. The limit exists at c. So the limit of f of x as x goes to c exists. So that is a real value. And the third thing, the limit of f of x as x goes to c is equal to f of c. Okay, these 3 things have to happen for a function to be continuous. Now, what points are the function continuous? Well, here we're looking and I have y equals 1 over x minus 2 minus 3x. So the first thing you should notice is I have this fraction here. Well, when I have a fraction, I can't divide by 0, so I need to kind of solve that out and figure out what value is going to give me a 0 in the denominator. Well, that's x equals 2, right? So we know x cannot equal 2 because then I would have a 0 there. Well, it doesn't say what values can I not have. It says what points are the functions continuous. So at what point is this a continuous function? So I can plug in all the values but 2. So I go from negative infinity up to 2, union 2 to infinity. So all the other points are going to make this function continuous. Now, properties of continuous functions. So if I have 2 functions or multiple functions that are continuous at c, I know the sum is continuous. So f plus g. So that might be x squared plus x. X squared plus x is a continuous function. F minus g. So the difference is going to be continuous. X squared minus x. If I multiply it by a constant, it's going to be continuous. So this might be something like 5x squared. If I multiply them together, x squared times x, this is still continuous. In fact, that gives me x cubed, which is continuous. Now this one, f, so the quotient f over g, where g of c does not equal 0, is continuous. So in our example over here I have 1 as my f of x function, x minus 2 is my g of x function. So I am continuous everywhere except that g of c equals 0, okay? So here I have x squared over x. I'm continuous everywhere except at 0. So if I raise it to a power, I'm still continuous. X squared to the 3rd power, I'm still going to be continuous. If I root it, I'm still going to be continuous. If I take a continuous function and I take the root of it, I'm still going to be continuous. Okay? So the composites of continuous functions. So if I have a function inside of a function, it's still going to be continuous. Okay? There may be some restrictions, but that's what we're going to be looking for. Okay? So if f is continuous at c and g is continuous at f of c, then g of f of c is continuous. So if I know that the inside part is continuous at a point, and I know its range or its y value is continuous in my outer one, I know it's continuous. So here's my composition of functions. So I have y equals the square root of x squared minus 2x plus 5. G of x is continuous. G of x is the square root of x. It's continuous from 0 to infinity. So then I have this f function, which is x squared minus 2x plus 5. It's continuous between negative infinity and infinity. Okay? So let's say I take 0. Okay? So I'm going to take 0. I'm going to plug it in here, right? So f of 0 equals negative 5. Now, negative 5 is for f of x, it says it's continuous, right? But can I plug that into my continuity of g of x? Is that going to make it a continuous function? No. So this is an example here of where I do have continuity, but I might have continuity where it splits, okay? Where this equals 0, okay? I'm going to end up having that value be greater than that 0 or less than that 0. So this is going to have 2 0 points, and we're going to split it, and then that will be continuous on those. On the positive side, between 0 and infinity. All right? So that brings us kind of to our last piece here. Kind of erase this so we get this out of the way. Is our intermediate value theorem. So an intermediate value theorem, basically what it's saying is it says if f is a continuous function, so it's very important that it's continuous. It doesn't have any jumps or breaks in it. Okay? It has to be continuous on a closed interval. So a and b have to be values, and it has to be continuous through it. And if y of 0 is any value between f of a and f of b, then y sub 0 is equal to f of c. There exists a c that is in between a and b. So what that's saying is if I found two y's, okay, so let's say I have y sub 2 equals 7. Y sub 1 equals 5. And I know that y is a continuous function. I know that somewhere between these values here, and we'll just say that this is x1, so let's say it's 1, 5, and 2, 7. Okay, these are my 2 points, and I know I'm continuous. There exists somewhere between 1 and 2, we're going to call that c, where f of c equals 6. Okay, that's what it's saying. It's just saying that there exists somewhere. So our example here is that it says f of x equals x, this is supposed to be x cubed minus 1. Show there exists a c such that f of c equals 0. Well, let's plug in 0. F of 0 equals 0 cubed minus 1, which is minus 1. F of 2 equals 2 cubed minus 1, which is 7. So notice here that I have negative 1 to 7. So there's a value from 0 to 2 that encompasses everything between negative 1 and 7. So there has to be some value, f of c, such that it equals 0, right? And if I look here, it's actually f of 1, because I have 1 cubed minus 1, which is 0. So 1 is between 0 and 2, okay? And it's going to make it 0 because I have a negative and a positive, so it has to have that 0 in between it. Okay? I hope that helps you guys with continuity and continuous functions.